Boyle's law. As you can see from the graph in front of you, there's an inverse relationship between the pressure and the volume of a gas, assuming that we keep the temperature constant, that it's not changing. What's so unique about an inverse relationship is that at any point on the curve, the product of the pressure and volume will always equal a constant. Therefore, we can derive an algebraic expression for Boyle's law. Since any point on that curve, the pressure times volume must always equal the same value, we can have an algebraic expression that says pressure times volume must equal a constant. Therefore, P1V1, that is one set of conditions, must equal P2V2, a separate set of conditions, because the product of pressure and volume is always a constant for an inverse relationship. So see how we can use this type of relationship for Boyle's law to solve a gas law problem. What we're looking at here is we have a gas under an initial set of conditions. It's at 760 torr and it has a volume of 250 milliliters. We simply want to know if we change that pressure from 760 torr to 2 atmospheres, what would our new volume be? Well, the first thing we have to make sure of is that we have a common pressure unit. So I'm going to recall that 760 torr is the equivalent of 1 atmosphere. So in essence, we're asking, when the pressure changes from 1 atmosphere to 2 atmospheres, what's going to happen to our volume? Well, there is an inverse relationship between pressure and volume, but we can solve this using our algebraic expression, which you see below, that says pressure 1 times volume 1, that is at the initial set of conditions, must equal pressure 2 volume 2 at the new set of conditions. So if you plug in the values relative to the algebraic expression and solve for V2, then you're going to be able to get that our new volume at the increased pressure from 1 atmosphere to 2 is going to be 125 milliliters. The second way of solving this problem, using what is sometimes referred to as the fractional method, takes into account the inverse relationship without using this algebraic expression. It would look like this. What we see here is that sure enough there's an inverse relationship between pressure and volume. That means as one variable goes up, the other variable is going to go down. Here we're noticing that our pressure is increasing, so if our pressure is increasing by a factor of 2, our volume would have to decrease by a factor of 2. So here we see that we started off with 250 milliliters and our volume would have to go down to 125. We have to take half of the 250. So once again, if the pressure goes up by a factor of 2, the volume would have to go down by a factor of 2.